Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 198, House Robber. For this problem, we're a professional robber and we plan to rob houses along some street. Each house has a certain amount of money stashed, and the only constraint stopping us from robbing each of the houses is that adjacent houses have security systems connected, and that means it will automatically contact the police if two adjacent houses are broken into on the same night. So we're given an integer array nums, and this represents the amount of money in each of the houses. So we simply want to return the maximum amount of money we can rob tonight without alerting the police. So as always, let's go through an example. So this is the integer array that we're given for this example, and each of the elements represents the amount of money at that house. We want to maximize our robbing pattern so that we can get the most amount of money in one night. The most important constraint that we need to keep in mind is that we cannot rob two adjacent houses. That means, for example, if we decide to rob the first house, we cannot rob the second house. Moreover, for the third house, we have the option to either rob it or we can skip it if we find a better way to get the most amount of money. So for this example, the maximum money that we could get is $4. And this is the pattern that we follow in order to obtain that money. So the question to solve this problem becomes, which houses do we want to rob? Well, we could make a decision tree and consider all the possible options of either robbing or not robbing one house. But that would be a brute force approach and would take significantly longer than the optimal solution. Before we actually delve into the solution, it's important to realize how we actually obtain the most amount of money in one night. Well, we can break it up into sub-problems. So let's say we rob the first house, then for the next part of the array, and then we have to decide whether or not we want to rob the first house. And in this sense, it becomes sort of a recursive problem where we break it down into sub-problems. So let's consider how much money we can make up until a certain point by robbing houses. And we'll go from left to right just because it's more intuitive that way. Let's consider the most amount of money we can make up until house 1. Well, the most amount of money is either if we decide to rob this house or leave it. Well, if we rob this house, then we get $2, and if we leave it, we get 0. So it's in our best interest to rob this house given no other information. Then let's consider the maximum amounts up until house 2. Well, if we rob house 1, we know that we're making $2, but if we decide to rob house 1, we cannot rob house 2. And vice versa. So if we do not rob house 1, we can rob house 2. So let's say we don't decide to rob house 1 and only rob house 2, then we can make a maximum of $1 until this point. Okay, now let's take a look at what happens when we get to the third house. Well, we can either rob the first house and the third house, or we can decide to only rob the second house and see the maximum amount we can make until this point. If we take the first option, which is to rob the first house and the third house, then we will get $2 plus $1. So that's $3 that we can make from the first option. But if we decide to only rob the second house, that is option 2, and we can only rob this house, so it's $1 that we make. That means the most amount of money we can make until the third house is $3. That's by robbing the first house and the third house. So the values until this point are 2, 1, and 3. Now it's important to realize the trick that we use to get this value is simply by looking at the previous two values in the array. So we had two choices. We could either rob the first house and the third house, or only the second house. So the way we get the value for the third house is simply by taking the maximum of the first house plus the third house. So we'll refer to the first house value as previous one. So we can say previous one plus the current house value, or we can refer to the second house as previous two, and we simply evaluate this to get the third house value. Then can we repeat this exact calculation onwards until we get to the end of the array? Well, yes, we can. We can just move the pointers, the previous one and previous two, as we're traversing the entire array. We just have to keep track of the two previous houses and evaluate the current house until that point based upon the result of the two houses before it. So now let's take a look at what happens when we reach the end of the array. Well, this is what we're currently trying to either rob or skip, and we want to keep track of the previous two houses. Well, we know this value is not the most up-to-date value. The most we can rob is everything before it. And so 2 is the most that we can rob until this point. So we have to update the values when we're going and calculating the maximum value. So this really becomes the maximum of everything that came before it. So in this case, it's 2. Then again, we perform this calculation, and again, this is previous 1 and this is previous 2. So either we have previous 1 plus 2, which is going to be equal to 4, or we have previous 2, which is equal to 3. So the maximum amount of money we can rob until this point is 4. Well, what is the time complexity for this algorithm? Well, we know that we just have to traverse this array, so we can do that in big O of n time. And we can just use previous 1 and 2 pointers to update the values. So we use a maximum of big O of 1 space. With that being said, we can go ahead and try to code the optimal solution on LeetCode. Okay, we're on LeetCode and we can start writing the solution. So we can begin by initializing the previous 1 and the previous 2 pointers. And we initialize them to both be 0. Since we haven't robbed any houses until this point, we are at the start of the array. Then we can go ahead and traverse the array. So we can just write for num in nums, and the num is each of the houses respectively. So we can calculate using the formula and store it in some variable. We'll call it rob, and we'll store the maximum of previous 1 plus the current house value, or previous 2. And then we want to shift the pointers over so that we can use it for the following houses. Well, then we want previous 1 to be previous 2, and then we want previous 2 to be exactly the rob value, since that's what we calculated to be the most until that point. Finally, we can just return the value previous 2, since that's the pointer that's going to be at the end of the array. Now we can just go ahead and submit the code, and hopefully it is accepted. And you can see the code is accepted, and this is the optimal solution running in linear time. So hopefully this video helped you and you learned something, and I'll see you soon.